It doesn't go up and down too much, and I'm going to be talking for a while. So interruptions are welcome. So quickly, who Search Discovery is, we are a data transformation company. We kind of have our roots in, it's going to be a big shock, our roots in, anyone? Search, yeah. Which kind of evolved to digital analytics and is now broadened into kind of the much broader kind of BI data science world as well. We still have kind of very, very strong groundings in the digital analytics world. But we try to help businesses use data with purpose to drive measurable business impact. We kind of run the gamut of services, everything from kind of data strategy, helping them figure out how to, I probably should have been really nervous that there were Search Discovery people here who could report if I botched the first 2 slides. So I don't know, I'm going to have to pay Mark to cut this section from the...
I'm deleting it right now.
The video. Don't tell Ron, don't tell the DAA that Rhonda skipped a few slides on the DAA page. So we kind of span the gamut from strategy, helping figure out what makes actually the most sense for you to pull together to use data effectively, all the way through the data collection, the data implementation, the data engineering, all the way through analysis support, data science support. So we kind of run the full gamut with the goal of actually helping organizations kind of build their own internal capacity to use data effectively. So enough about us. So these are kind of seem like the big 3 hot topics these days. Remember when it used to be big data and everybody argued about what big data was? So now it's kind of machine learning, artificial intelligence, data science. And I want to cover machine learning and artificial intelligence really quickly, just because maybe some of the digital analyst side, or there's still kind of confusion as to kind of what the difference is. Anybody seen this? Like, this is the best example that if it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's probably AI. I've actually tracked down that he was the original guy, but I'm really just sharing that for kind of nerd humor that you now can take back to your workspaces if you hadn't already heard it. So that's kind of the extent that we're going to really talk about machine learning and AI. So questions like, what is data science? And I was talking to some people earlier, like I had this naive idea that I was coming from almost 2 decades in analytics, that I was going to become a data scientist. And I've sort of realized that I'm not going to become a data scientist, but I definitely over the last 3.5 or 4 years have started doing some data science and actually gotten an enormous amount of value out of that. But still definitionally, like what actually is data science? And it turns out if you ask 20 data scientists to define data science, you'll get 20 completely different answers. At least 19 of them will use a Venn diagram to define data science. This was a few years ago, somebody on KD Nuggets went through and literally just tracked down Venn diagrams that were defining data science. So I'm not going to give the definitive definition of what data science is. Digging into data science has got me back into statistics a little bit, so I'm a little comfortable with uncertainty. So this is kind of my 85% confidence Venn diagram. It's super high level, and we can put different labels in here, but it's kind of the intersection of these multiple disciplines. So computer science, or programming with data, the statistics side of things, or modeling, and then subject matter expertise. And this is kind of an interesting group because I suspect the people who are kind of coming through the data science and BI meetup may have more of kind of the computer science and statistics around this topic. The ones coming from the digital analytics side, we mostly have a lot of domain expertise around digital analytics, and they all kind of have to come together. And it's a real challenge for the people who say, I'm going to do a 12-week boot camp and I'm going to become a data scientist. Like, you can't get subject matter expertise. Really, you can't ramp up as much as you need to on everything. It's a good kind of jump start. So what I'm going to try to do is maybe change the way you think about data a bit with some examples that you can try out on your own data, with one caveat. So we're going to we're just going to walk through a bunch of examples and hopefully make it kind of interesting, kind of actually have an internal site search example. So, nailed it, right? That's what you do, right? Yeah, okay. Maybe, or maybe it's like, maybe you'll be the one who stand up and yell, fraud! That's more than this. So we're going to talk kind of around those different circles in the Venn diagram, because what I've found is that just doing things in those individual circles as an analyst, boning up on statistics, getting more familiar with programming with data, that has been a great way for me to grow professionally and add more value for the clients that I work with. We're going to touch like super lightly on text mining, because that's data that we have an enormous amount of, and it turns out that coming from the digital marketing side, there's stuff we can do with that. We're actually going to hit linear regression, which may put a few people to sleep, but we're going to talk about it with kind of, because there's a little part of it that there will be some people that hopefully it kind of blows their mind a little bit. Even though it's like super common, we basically understand it, but hopefully we can walk through like where it can get confusing and kind of a super high level interpreting it. And then the thing that kind of, when my brain kind of exploded, was when I first understood time series decomposition. So in the world of digital analytics, most of the data we're working with is time series data. It is all, there's a timestamp for everything somebody does. And when you look at like degree programs that teach like statistics, masters in statistics, time series is like the third or fourth semester. It's a super complicated topic, and yet it's the data that, coming from a digital analytics side, that is fundamental to the data that we work with. So there's some kind of cool stuff in that as well. So statistics, we all know the normal distribution. So I basically said I'm going to walk through 4 examples, and my expectation is that hopefully kind of everybody will find like at least 2 or 3 of them to at least be kind of mildly useful or thought-provoking. But it's a mixed crowd, so totally get it. There are going to be some outliers out there. There may be an example that you're like, that's kind of a stinker, but just know another example's coming, so stick with me. And my hope is that for some of you, there's like at least one example where you say, that's pretty cool. Like I could apply that to what I do, or that's made me think, or that's made me understand this space a lot better. So that's kind of the goal. So next piece of audience participation. I know all the DAA-oriented people, but show of hands, how many people, I'm hoping the other ones, have access to at least like one, like a Google Analytics account? So decent chunk, okay. If you don't, and you're interested in this topic, Google Analytics, it's free. All you gotta do is find somebody who's got a website, get access to their Google Analytics, or offer to implement it for them.
They have free data now as a demo.
They do. They've got the merchandise store, which has a very weird thing that happened in November that nobody can explain. The transactions and revenue like fell off a cliff, and we can't figure out why. But yes, you can actually get free if you really just want to play Google's merchandise store. Actually, there's a demo account. You can log. You can get through the API, or you can get through the web interface. So, and the way this is set up is there's no coding required, so all the examples were done in R. The R is available, but if you just want to kind of play around and try this out, if you have access to Google Analytics, or actually if you want to, actually haven't tried it with the Google Store, now that I realize I could, you can even try it out with their data. But the idea is that if you're interested in this data at all, you want to try it with your own data to see, does it work, does it make sense? I'm using Google Analytics. It works. Obviously, the ideas all work with any digital analytics data, but Google Analytics is kind of more broadly available than other platforms. So let's start with kind of a example that's blending of the computer science and subject matter expertise. Every one of these kind of has to use some subject matter expertise. But again, kind of need to step back for just a minute and talk about what programming with data means. And definitely in the digital analytics world, generally people are talking about R or Python, and there sometimes is kind of an assumption of SQL under the hood. There's not a one of them is better than the other. There are more similarities to the 2 platforms than there are differences. They're both programming languages. They're both open source, which means you don't have to ask your manager for budget to get a license. You can run them. You can run them in a browser, both of them. They're both supported by huge communities, which is awesome. So coming from the digital analytics world, we have like a really pretty long-standing, very supportive digital analytics community, and it is tiny compared to the community that supports both Python and the communities that support R. And then for today, like they're both readily connectable to lots of data sources. We're going to kind of focus on connecting them to digital analytics data sources, but certainly we can connect them to other data sources as well. And we'll talk lightly about some social media stuff. So first example, and now for those of you who are no exposure to Google Analytics at all, I'm going to hopefully try to kind of explain kind of the subject matter, give you a little snippet of the subject matter expertise as we dive into the example. So this first one is kind of called a time normalizing page views from the launch date. So what does that mean? Well, imagine that you're a website and you do content marketing. You push content out periodically and you want people to come read, consume that content. So this is like 2 blog posts, and this is the traffic to those blog posts. Everything's time series. Traffic to them by day. So the first one launched in January, had a big spike, and then fell off, and then just kind of other little traffic trickled in. The other one launched in May, that fell off. It's got a few other little bumps. Well, which one of these actually did better? Like which one drove more traffic? It's really hard to say looking at it this way. So time normalizing says instead of taking the date that they launched and kind of the way we're used to looking at that data, what if we kind of looked from day 0 and kind of normalize them, so we're looking at the number of days since the page launched. So now we're kind of comparing them apples to apples, and saying how do they do for the first 60 days in this case. But it could be 30 days, or it could be 90 days, or whatever. It's still kind of hard to tell. Doing just this step is something that it's actually tough to do with web analytics data in the tool, in Google Analytics, in Adobe Analytics. It's getting easier in Adobe Analytics with some of their cohort stuff. It's actually kind of tough to do in a spreadsheet, because if you imagine what the data looks like here, with just 2, I could do it. I could export all the data, and then I could say, let me just copy and move this column up and then put them side by side. It's not hard logically. Like I can tell when that second blog post launched. I know what day 0 is as a human being, but if I'm programming with data, I can say, what is the logic? Well, I'm going to go through every day for each page and say, what's the first day that it had enough traffic that it looks like that was the launch date, and then kind of refactor it so that I'm lining them up and kind of creating a new variable, which is days since launch, and now let me plot it. Still kind of hard to tell which one of these did better, so I can also programmatically say, let's go ahead and do a cumulative data instead, and let me look at cumulative page views since launch. And now it's very, very clear that after about 20 days, the second blog post had actually generated more traffic. And we're just using traffic. Unique page views is kind of a term for traffic. It could be kind of any metric. So this comes in handy if you have a bunch of content. Not that useful with just 2 pages, but if you wanted to look at everything on your, like maybe every blog post, and you want to see which ones actually look like they're generating more traffic over time, and do it in a way that's kind of interactive, maybe filter it down to a subset of the data, you can do that with by programming with the data. And this is all would just be tough to do in a spreadsheet, and tough to do if you're bringing digital analytics data into a BI tool. You wind up kind of having to bring in you're typically bringing in kind of a flat table of some sort, and that transformation can get kind of tricky to pull off within the formula. So, to mix it up and to walk on a live wire, I'm going to show this. So all 4 of these examples, there's one link at the end if you want to go try them out yourself. They've got links to all of them, as well as a couple other ones that we're not going to look at today. Now, even though I tested it when I got here, it's going to, okay. And it will pop up. It will probably give you kind of an alarming message that this app has not been approved by Google. So you'll just have to make judgment over the course of this evening whether I'm trustworthy. I'm not doing anything. I just don't know how to get an app fully approved by Google. But you get this tool. I mean, I kind of looked it up and it seemed like a lot of work. So, so we could look at this podcast, this amazing podcast called the Digital Analytics Power Hour. That's, if you guys are filling in the blanks, be on the nose, it's 2019, so we don't have blogs now, we have podcasts. So I can just run it, and it's going to go and query the data and pull it back. And shocker, if you do it just with all your data, a lot of times, guess what? The homepage has the most data. So you can put in a little bit of regex, and maybe I want to say only the shows that have launched in 2019 let me pull that data again. And you can start saying, now I'm comparing apples to apples and which one of these are really taking off. And this is like a ITP. So in building an interactivity, and this is why I used R. For those of you who are, how many people use R? Right, okay. So you guys use Shiny? Big Shiny fans? Okay. So, play around with different, I don't want to look at the first 30 days, maybe I want to look at the first 60 days and then recalculate. So that's kind of the first example, but the key is that stuff that trying to get out of a spreadsheet or trying to get out of a static set of data and saying, I want to kind of tell it what I as a human being would do, and I want to do it at scale, and I want to do it in a way that I can actually reuse it. Okay, and I can do a survey and figure out where on that bell curve this one fell. So that's basically just advanced data manipulation. That's not really data science, it's just doing stuff programmatically with data, and there's a ton of things we can do with that. So in the world of digital analytics, we're always talking about attribution. How do we actually figure out which marketing channel we really want to give the credit to? If somebody came in through organic search and didn't buy, and they came back a week later through a paid search ad and they spent $100, what do we give the credit to? And one way that I like to look at that is take a whole bunch of different models. We could split it 50-50, we could give it all to the first organic search, we could give it all to the last, and there's all sorts of these advanced heuristic models. And so this was Adobe Analytics data, but it would have taken hours to go and pull. I wanted to compare all of them and just say, let me look and see how different is that data. Working in Adobe's web interface, it was going to be really unrealistic to keep changing a bunch of settings, export the data, change a bunch of settings, export the data again. But because I could programmatically pull it down, run a bunch of logic on it, and I've crammed a whole bunch of data into just one simple chart where I can now actually get a sense of how much does it really matter if I use a different attribution model? Does it differ in a way that I actually care about? Should I go and spend a whole bunch of money with some other technology to do some sort of fancy stuff? And usually the answer is no. So that was kind of a super useful. This is a way that, and this was my foil, Jamarius Taylor, actually. I was unsuccessful making this work, and then he had to show me up and made it work. But right, it's hard to do network diagrams certainly in a spreadsheet. Some BI tools, maybe they're different. The idea of edges and nodes. And so we had this discussion around what if we treat the pages on a website as the nodes and movement between those pages as the edges. That might actually help show us where there are kind of natural pockets and locuses. You really got to look up. What's the plural of locus? Anyone? Loci? Loci?
I think I heard a loci.
Can you get some audience interaction here?
Yeah.
But this was something we could actually, color code it based on what directory was that, what was something in the URL. Change the node sizes based on how much traffic went to the page. There was a lot we could do that was not available natively in the digital analytics platforms, not something we could do in a spreadsheet, but something that we could start looking at and figuring out, understanding how a site was actually performing. And then another super common, big, hot topic in digital analytics is cross-device activity. People are on their phone and they're doing some stuff on my site, and then they're going on their laptop and they're doing some other stuff, and how do I tell that's the same person? And sometimes it's like, well, it's hard, and the privacy meets reality is kind of tough. So, but if we pull a bunch of raw data, we did this for a client that we had to pull, I think I had like 1.3 million rows of kind of raw data, and so let me programmatically, it was essentially just a monster of a VLOOKUP to say for the ones who I can identify because they logged in on their phone and they logged in on the desktop, I'm trying to get some base level understanding of how many people are interacting with this brand across multiple devices. Not perfect, it's still conservative, it only worked for people who had logged in both devices, but ultimately I was like, oh, it was 1.3 million rows of data and it resulted in 2 ovals and a number. So but I was pretty excited about it. And then really took that 10.3% and started digging into those a lot more and saying, okay, what were they doing? Which one did they visit first? Are they coming to mobile first and then they're converting? But once you hit 1.3 million, you're definitely out of Excel. Your BI tools can maybe handle it, but I actually had to put a lot of logic in to kind of stitch stuff together. So there's lots of opportunities just from programming with data and thinking, what am I trying to figure out and what data is available to me. Okay, that's example number 1. Anybody hungry? Need to fake a restroom break? Never come back? Okay. All righty. It's like Giannis guarding the door. People are sleeping.
Doors. You guys are just staying here.
Is it getting warm in here? Or am I just talking? Okay, so now we're going to kind of take programming and kind of combine that with a little bit of text mining. And I'm actually not ever super clear whether text mining fits in the statistics circle or the programming circle, but it doesn't really matter. This is one of my favorite examples because it's actually using text in a way that, for coming from a digital analytics world, we've always kind of struggled with text. But site search, when you go to a site and you type something in, that is the voice of the customer. It's the customer speaking in their words what they're trying to do on your site. Your site may have a terrible search engine, but the customer thinks it's Google, right? They're typing it in. You may not deliver good results to them at all, but they've already told you what they're looking for. So what can we do with that data? So the standard, and if you're using Adobe, you may have an EVAR for your search term and an event for your search, but in Google Analytics, it's a simple little configuration that works for most search engines, and this is kind of a standard report you get. So the example data is kind of hard to find good example data for search because it kind of totally gives away who the client is. So the setup on this client is they're basically kind of a crafts type store. So think like a Hobby Lobby or a Michaels, that kind of store. And this is what their search terms look like. And I can immediately see that it's kind of messy because I've got Google Analytics is case sensitive, so it's going to put Canvas there twice. I'm like, gee, if I was doing this in Excel, I'd force them all to lowercase and at least combine those together. But that's clearly probably my number 1, but things overall get messy. And if I just took this, so there's sort of 2 things we're going to do. The first really is no data science, but I learned this from a lady named Nancy Coons, credited there in the bottom, years ago. And she said, some people will come to your site and literally type in a question. And it's not that hard to identify which questions are, because in the English language, we start questions with one of only a handful of words. So one thing you can do is just go and you can do this right in the interface of your website and just filter for searches that start with how, what, why, when, where, who, and you get a list of questions. And they're going to kind of mostly live out with pretty low volume, but they can tell you this is what some people were actually looking for. This is also where this example breaks down because guaranteed people were not really looking for how to train their dragon. They weren't really wondering where the wild things are. But you get the idea. You got those movies. But generally, you could quickly scan this and say, oh wow, people are kind of looking, how to draw, or how to make slime, how to make a wreath, and then you can kind of go back and use that as a jumping off point for some deeper analysis. So that's really just like a simple filter on the report that I've always loved, and it's kind of like the joke about AI and machine learning. I want any digital analyst to, I think there probably is a recipe on the DA's site for that. Pretty sure Nancy would have written that. Okay, but what if we actually want to do some text mining? Well, if we took just that raw data and threw it into a word cloud, and people either love word clouds or they hate word clouds. They're certainly not super precise. I contend that a lot of people hate word clouds because that's what they do. They take the raw text data, they go to wordle.net, and they throw it in, and they see something like this where they're like, well, frames and frames, canvas and canvas. Like, that's kind of messy, it's not that useful. So I'm going to walk through text mining 101 at kind of a individual word level, and then we'll kind of see how this looks after that. Oh yeah, and then frame showed up smaller over to the side. So we're going to do a little bit of light text mining. first thing we're going to do is called unnesting, and just pointing out some of this stuff, super easy to do in Excel, some of this stuff, pain in the ass to do in Excel. So unnesting, in this case, we don't always want to do this with text, but in this case, we're just going to focus on just the individual word. So that means that if we've got a phrase, like we've got Mason jars was searched for 12,980 times, we're going to say, well, that means the word Mason was searched for 12,908 times and the word jars. And that would be kind of tough to do in a spreadsheet without writing a script. For cases where somebody searched just for a single word, we'll just bring that one word over. So we just made our data set a lot longer. So easy to do with a programming language, tough to do in a spreadsheet. The next thing is, in this case, in digital analytics, we could, at the point of capturing the search term, we could force it to lowercase. We could do it when we bring it into the platform. We could force it to lowercase, you generally should. But even if not, it's not that hard. This would be super easy in a spreadsheet to do. So we're just going to say we want to treat all of those as being identical. So let's convert them all to Canvas, to all lowercase text. The third thing we're going to do is finding word stems. And word stems, again, kind of basic text mining, sort of like the root of a word. But word stems are a little bit different in that they don't necessarily result in an actual word. Like I suspect the word root for all three of these would be graduate or graduate. But the word stem, it just kind of truncates a little bit more, kind of knocks it down to just this 7-letter word pronounced who knows how. And these are different words, so we're now definitely transforming the data, but the idea of what they are, they're all around graduation. One is the event, one is the actual person, one may be the verb, given the site is probably the gifts for graduates. But I'm going to treat all those as one kind of idea. Let me kind of get them all sort of truncated down to that same thing, to that common value. And this is, again, easy to do with a programming language. I'm not sure how you would do it with a spreadsheet, and I'm not sure whether BI tools, how well they would necessarily handle it. It may take, I don't know, some additional scripting. But this would confuse my audience if I said, wow, there were like all these people searched for this word. They're like, wow, like ironic that they're searching for graduate and they can't spell. So that would cause a little confusion. So we can do one more step and say, well, all those words that got condensed to the same word stem, which one was searched for the most? And let's kind of do one more step of transformation and use that. So I've definitely changed the data. I've changed graduates to graduation. But I'm okay with that because I'm trying to get a sense of kind of what are people looking for on the site, and that's going to be good enough. But I want to do that at scale. I want to do that with the tens of thousands of rows of searches. And so then the last thing is removing stop words. Because we're not using phrases, we're looking at individual words, there are a ton of words that we don't really care about. Articles, prepositions, conjunctions, that aren't in their own isolated, when they've been split out as their own word, they're not going to be that useful. So I kind of want to just knock those out. And those are readily available as well. You can say, now take that whole data set and just remove all the stop words, because that's the sort of thing that causes all this weird little clutter in a word cloud. Let's go ahead and clean that out as well. So this is what the original data set, the top, I don't know, 20 or so rows looked like. After I've done all of those steps, and then I've basically pivoted, I've condensed them. So all the words have been kind of collapsed and summed together. It's a pretty dramatic transformation. So this is, well, both of these are technically called a term frequency matrix. For some reason it took me a while to think through what that meant. It's like, oh, it's the frequency of each term, and it's in a table, but we sound fancier if we say matrix. So the frequency of each term in a matrix. But it looks hugely different. So I thought, when I looked at the data initially, I collapsed Canvas, it's number 1 and number 2, surely it's going to be up there. By the time I've done all this transformation, it's dropped down to like the 8th spot. Looking at the volume, so we did that exercise. So the frames, if it was just the ones that were in the 3rd and 5th position, that would have been like 40,000 searches. But that existed, so wood frames, painted frames, metal frames, clearly existed so often throughout the long tail that there were like 305,000 searches that used some form of the word frame or used frame in a phrase. So what does that do to us? Here was our original word cloud, which maybe not awesome. And then this word cloud, which starts to have some real differentiation. I don't see the repetition. And I've started to get something that might actually have a little more context. And actually, I feel is a better telling the story of what people are actually coming to the site and searching for. So there's another step that occasionally will happen, and it doesn't really happen in this case, but like I worked with a shoe retailer, and guess what happens if you do this exercise on a shoe retailer site, and then you do this, like shoe, like cool whip, and that is not interesting at all. So while we have stock words that we definitely want to remove, sometimes we also may say, and this is kind of fictitious, if frame was kind of my shoe equivalent, I may want to look at that and say, you know what, these words are so core to what we do, they're not actually that interesting. So I'd like to be able to quickly specify and do a little bit of kind of manual tuning of this and just knock them out and generate a new word cloud. So is there anybody who's like their blood is boiling because they hate word clouds so much? Who will admit it? Okay, that's good. Maybe you're just being very polite. There are definitely people who have strong feelings. So that all is like super logical, and I've done this and talk about another example in a minute. But we can follow that all pretty easily. It's all logical steps. We can put that, we can write some code, we can do that with kind of any set of data where we think the individual words would be useful. And in digital analytics, some sites it's useful for, sometimes it's not. But there's actually, we can take it a step farther. And this, I don't fully understand LDA. I don't even know how to pronounce the second word. I've read through it. It's one of those things that I read through and I'm like, oh, I get what that's doing. And then like ask me 10 minutes later and I'm like, God damn it, I lost it. But there's actually a lady, Julia Silge, I think that's how you pronounce her last name. Anybody know Julia, the tidy text lady? Any of the R people? She's got a really good description of what this is, but you're basically doing cluster analysis just with that same original data set after it's been kind of cleaned up and scrubbed. You can basically start to have it just, it's kind of an unsupervised learning operation where you have to pick how many different groups do I want to put this into, and then just with that raw data, it can start bucketing it out, which can be very useful on a site to start figuring out what kind of the themes and topics are. Our in-house like actual data scientist was yesterday. I was chatting with him and he said he was going to do some topic identification stuff with. I'm actually not remembering what the data set was, and I was like, oh, "You going to use a little LDA there?" And he was like, "Well, yeah, it might be LDA. It might be something else I've never heard of." And I was like, "Let me just scurry away before he realizes that I was just trying to." I was kind of making a joke, but apparently I actually hit on something. He was like, "Yeah, LDA is really useful." So we had a financial services client that this actually did sort of work out. We could tell there was kind of a bit of a theme around people who were sort of looking for kind of payment kind of information, kind of their transactional type stuff. And there were other people who were kind of more looking for like auto loan type stuff. So it was kind of interesting. More often than not, for site search data, it doesn't really pan out with a lot of useful stuff, but it's pretty easy to try. So here, I'm going to try, not my foil, but somebody else, Michael Helbling, not just a longtime member of the DAA, but a board member of the DAA, and my podcast co-host, and close personal friend, as I'm stalling. This is weird. Let's see, I'll zoom in. So I'm going to use the podcast site as well, which has no search box on the homepage, which is a sore point. But we're going to pull data for like the last month, and we can see kind of it pulls this up. This is using Google Analytics. Not sure exactly what he typed in today. You can kind of quickly sort of scroll through.
You don't have the date range anyways. So.
Oh, did they? Quick. This is going to be, we get an enormous amount of traffic, but I'm still going to take multiple months so that maybe we get something of use. Date 20th. Fail.
It's okay. Now that I see what you're using it for, I'm really glad.
Really? Oh wait, I just saw one. I'm kind of glad that one's not working. That's unfortunate. So this walks through, and if you want to try it out, then you can generate. The fun thing about small sites is you can really play around with it, and this is almost certainly not going to work in data and analytics. So clearly need to fix whatever that bug is. That's irritating. I can walk through all of these. Yeah, if things are really getting raucous in here, I'll stop and debug code on the fly. So, but you get the idea. You get the idea of what it should do. So that's kind of text marketing.
So why is your hair so nice?
What? That man wants a job.
Volume.
Anyone wants to talk about dry shampoo? I don't use dry shampoo. It was a phase. I went through it. It was a misunderstanding with my wife, and my hair got longer. Moving on. So there's a lot we can do with text mining, right? That was kind of, I like that one because it's like, this is data many websites have access to, but there's other stuff that even just being in marketing outside of the website, it's fun to do this with like Twitter data. So taking all of the followers, and I originally did this with a company that, an organization that hired a new CEO, and he was coming from a role where he was very prominent internationally. He got hired to a very domestically oriented organization, and they were like, he's got a gazillion followers, but who are they? And so using the same basic exercise, saying I could go through the Twitter API, I can pull all or a sample of his followers, same sort of thing. What you write in your box, your profile on Twitter is you describing yourself as you want to be perceived on Twitter. So it was actually pretty useful to do that and get a sense of kind of who were the people who were following. So lots of stuff, I think just with that, looking at individual words and then word clouds and then digging in farther from that, or even doing that LDA work. In digital analytics, I feel like for years we talk about the power of the call center, but it's only been more recently that we actually have the ability to say, hey, if you're in the call center, if we get the data from the CSR, their notes from a call, or now that there's so much speech to text, and there are lots of services out there that are actually listening to the call and can translate it to text, there's lots we can do. Probably not going to the individual word at that level. At that point, you want to start dealing with kind of engrams and phrases, and there's other kind of natural language processing that you may want to do, but there's a ton of text data that has been digitized that we can start to bring in. And then we have not done this yet, we just keep talking about it, that is Google is kind of evolving the way that it is doing organic search, getting this idea of we can scrape our own web pages and do some forms of this text mining to actually figure out what are the entities, what are the topics that are being modeled. We can blend that with our digital analytics data. And we can start saying this topic, now let me look at some of the quantitative data that we tied to that, and what's it telling us? We can go point it, we can scrape our competitors' websites and compare that to what our own websites have. And we've had little bits and starts of internal discussions about it. I didn't know we'd have like a couple of our SEO guys here tonight, but now they're going to go and figure out what we're going to do with it. Already doing it? Just did it? Somewhat? Of course you are.
Do you care about negative keywords?
Negative keyword. Oh, that's a. I should. Yeah, I mean, to deal with negative keywords, you start to have to deal with kind of bigrams or n-grams and kind of subtracting it. I don't know how. It would be easy enough to say. Yeah, you could. Like, you could add another step if you think a lot of people are searching for, you know, picture frames, not the blue ones, or something like that. That's a. Not been asked that question. That's a good.
It's also a way that you could just quickly identify irrelevant traffic. Like, I'm thinking of negative keywords from like a media perspective. It would be, if they're not searching on your site, but if you're pulling like a search query report from AdWords or something like that, you could identify irrelevant traffic really easily through this.
So, yeah. What were you actually saying?
Just like scraping, maybe not sentiment, but context from the different, blog posts and content offerings on your site, and comparing them to the traffic that you have.
Yeah. So I think that's like topic modeling. I don't think I knew the phrase topic modeling until like a year ago, and now I'm like, well, that's like awesome. Just like I can upload a picture and find a puppy, the old machine vision example, it'd be great if I could turn, if I could digest my web content or my web content and say, these are kind of the topics that are in this page. Now let me take that, how many people viewed the page, how many people left the site from the page, so on and so forth. I think there's huge opportunity there, and at some point, we're going to have an awesome example of that. Yes?
So kind of stepping back from the data science to the strategy side, I mean, where do you roll in like people search when they're mad or when they're confused, and like how are these, basically how do you sell to a client or to a manager, because I came from, a corporation that was huge. How do you sell the idea of, sure, I'll run this kind of analysis for you, but are these people really, how are we going to make decisions based upon this? Because maybe they're just searching because they couldn't find it. We shouldn't change our whole navigation because of this, right? So,
right.
Yeah.
Well, and definitely, like, we jumped right into what if like 0.2% of the people are actually doing that. So yeah, I've got a whole other presentation around hypothesis validation, and I'm kind of skipping over the what's the actual business case. This is where Frank was like, that's what Tim's going to talk about. I'm like, got a whole other deck on that. This ain't it. So now I've reminded you that I'm maybe not delivering on the promise that Frank set up for me, but it's not going well.
It's going fine.
I'm dying up here. But I mean, that's like, that's to me, it's like take one example and then hopefully like you're like, wow, could I do this? Could I do that? Like that, to me, that's what I get excited about. And definitely from the digital analyst side, like, oh yeah, we should go and try that. Now the kicker is that there's a bit of a steep learning curve to, I'm going to learn R, I'm going to learn Python, which is yet another presentation that I'm not going to do tonight unless I'm here till midnight. But hopefully you get excited, sort of see the potential there. Wow. Does anybody know where this is going? So, we're going to do linear regression with nominal variables because this was actually something that it took me a little while to figure out exactly how to do using web analytics data. Because one of the things about web analytics data the way that the web analytics industry worked, all the data was aggregated. And that made things kind of confusing as to what's a dimension, what's a variable, when you try to kind of map statistics to it. So we're going to kind of sort of blend all three of these together, but in a this is like light data science light. So what we're going to do here is we're going to try to quantify the impact of the day of the week. So it's kind of time series, but not really, because we'll talk about how that works. Quantify the impact of the day of the week is kind of a way to sort of step through doing linear regression with web analytics data that we can get just out of Google Analytics or Adobe Analytics. So we'll start with the super basics like linear regression. We all pretty much understand it's the old formula of a line, y equals mx plus b. And we want to take that sort of formula and generate something where we're actually kind of predicting how much traffic. We're using traffic here, but it could be revenue, it could be orders, whatever we want to predict. We're just sticking with kind of a simple metric. And we want to do it with the day of the week. So the reason is because this is where I ran into confusion when I was trying to work with statistics, because I'm like, what's the actual variable? We have a bunch of these things that are categorical or nominal variables in digital analytics data. Day of week is not one we necessarily look at a whole lot, but we definitely look at where did our traffic come from, and what did they order, what are their sessions, and those different default channel groupings or marketing channels in Adobe, those are categorical or nominal variables. Same thing with what type of device. Are you on a desktop or laptop? Are you on a mobile device? Are you on a tablet? Are you on a gaming console? So what we're going to talk about applies to any of those, and some of that is actually really has a lot of potential for digital analytics. So here's our sample data set. We're looking at it as it shows up in the web interface for the tool, just sessions by day, and we're going to translate it to a formula. We're going to do a linear regression that looks something like this. And now we'll hit where I got confused, right? We've got sessions equals 52, got it, plus 203 times Monday. How does that work? Equals 193 times Tuesday. Like, wait a minute. Literally, I think it took me about a year to get past basically this issue, right? If you're telling me 193 times Tuesday, and then I'm like, now you're gonna ask me what 42 plus tacos is. This is not going well. So, and again, I apologize for those of you who know exactly how this plays out, but I'm counting on a few of you to be like, oh, that's not that hard, that's kind of cool. So here's what our data would have looked like that we're trying to do this regression on. And it seems like it's kind of obvious. You know, we've got the formula for a line, y equals mx plus b, y is our dependent variable. We know that we're trying to predict sessions here, so that's easy. So it seems kind of obvious that our x must be weekday. But that's where we get into that 192 times Tuesday. How do we actually use a nominal, a named variable, a categorical variable in prediction? So we start with our basic plot. And this is how digital analysts are conditioned to looking at data. We just see it that way, and these little humps are because we typically have dips. A lot of sites have dips on the weekends, go up during the week. That's kind of why we thought we'd try to check day of week. But if instead of looking at it this way, if we think how many Mondays are in this data set, and it's like, well, there are 12 or 13 of them, but they're kind of spread across every 7 data points. Same thing for Tuesdays, same thing for Wednesdays. So instead of looking at it this way, we want to group all the Mondays together, all the Tuesdays together, all the Wednesdays together, and then we can look at a completely different type of plot. We can look at like a box plot. So now I've got those 12 or 13 values for each Sunday grouped together, for Monday, for Tuesday, middle line showing the median, the 2 boxes are the second, third quartile. So we get a sense of kind of where do they net out at, kind of how much variability is in the data. And by the way, I kind of intentionally grabbed a not super clean data set. There are plenty of websites that look very, very repetitive here, and that makes for a very powerful regression, but not really one that's that interesting. So we have to start by kind of thinking about the data this way, which is kind of fundamentally different. This is not purely a required step, but to me, like, this was where the light bulb went on, that, oh, I'm talking about day of week. I really have 7 different variables in that one column of data. So we're going to transform this data in a way that we're not going to lose any information. And what we're going to do is we're going to create dummy variables. So we're going to take that weekday and we're going to spread them out and make a column for each day of the week, and then we're just going to code it as a 0 or a 1. So looking at a Monday, that means that for Sunday, we've got it as a 0, Monday it's a 1, Tuesday it's a 0, Wednesday it's a 0, so on and so forth. Now, some of you may say, looks like you ran out of room on your slide because Saturday's not there. Why did you only make 6 columns, right? What happened to Saturday? And turns out I have to drop Saturday. This is where you can start to, depending on who you're kind of nerding out with, you can be like, well, it's dummy variables. I always got to do a k-1. Saturday's actually there. Because if I look at Saturday, guess what? If it's not Sunday, not Monday, not Tuesday, Wednesday, Thursday, or Friday, it's Saturday. If I included Saturday, I would actually have redundant information. So again, like the next time I'm talking to our data scientist and dummy variables come up, we're like, yeah, you gotta do k-1, right? And he'll be like, yeah, and then he'll say something I don't understand. At least at that point he'll kind of acknowledge. So that logically makes sense. That's kind of cool. Now I've got a table of numbers. And then I'm not gonna go into the mechanics of everything that happens with regression. With this, you can do this in Excel with the analysis tool pack. So you can do it in any platform. But literally that little bit of transformation, which is pretty easy to do, now it's, whether you're using R or Python, it's literally like one line of code. So that's, people in R love to say that, like, and then with one line of code, I can do a regression. And the syntax, a little goofy, it takes a little bit to learn, but this is basically saying predict sessions, use every variable, every other variable to actually do that. And it generates a regression for me. Now I'm going to do one other step because some of those days might actually not be that useful. So if you remember back to statistics, you can kind of reduce the features by doing a stepwise regression, basically add and remove variables and say, is this variable actually helping my model or not? I want to have as few variables as possible in the model. So that's what kind of the second step does. And it might actually drop a couple of values. So that then generates this super intuitive set of results. Excel's looks roughly equally intuitive, but that's kind of where things get a little intimidating, I think. If you're like, I ran a regression, now let me look at the model, and holy crap, there's a whole bunch of numbers and abbreviations there. But we're gonna dive into a handful of the specifics of that, because you don't necessarily, all of this matters. If you talk to a pure statistician, they'll tell you why all of this is super important, but we're only gonna talk about 4 pieces of it, and I think it's actually kind of useful. So p-value, we remember p-values. We've got this kind of goofy annotation in R. It turns out that's really just saying the p-value is 4.354 times 10 to the minus 11th. We can kind of think, okay, that means we're moving the decimal place 11 places to the left. It means our p-value is basically 0, which means it's less than 0.01, which means we can say the model is statistically significant at a 99% confidence level. And then a bunch of people will descend talking about all the perils of p-hacking and p-value, and it's like, that's fine. This is actually kind of handy. You're gonna look at the damn p-value, and if you see a really small one, you generally say, thumbs up. That means that I can kind of declare statistical significance for the model. So that's cool. The next thing we're going to look at is the adjusted R squared. We have the R squared, we have the adjusted R squared. Why do you adjust the R squared? Because it's a little better if you adjust it. I don't know, there's a whole bunch of deep in the weeds stuff. The R squared is, you can look at the R squared if you want, it's about the same, it's close, it's just before it was adjusted. So you see this, and we remember, like, from working in Excel doing scatter plots, you drop a line and you say, what's the R squared? And this is one that I think gets kind of misinterpreted by a lot of analysts, because you're like, well, 0.4584, like, I want like an R squared of like 0.7 or 0.8. Like, this is like less than 0.5. What does that actually mean? So an adjusted R squared of 0.4584 is saying that 46%, well, 45.8% of the variation in sessions from day to day is explained by the model. Initial reaction, like, only 46%. And then I'm like, well, we got to think about the cost of data. And I'm going to charge you nothing to tell you that tomorrow is Wednesday. So that's really, really cheap data. So I literally took freely available data, very, very cheap to get, and I'm explaining almost half of the variability in the traffic to my site. So that actually means not bad, and that probably actually means I want to include day of week if I'm adding and building a more sophisticated model. There's a lot that just the day of the week is explaining about traffic to my site. So I think that whole R squared versus p-value is something that can kind of trip people up. And also people are like, I want an R squared. If an R squared is not at least 0.8, don't even talk to me. If your R squared is like above 0.9, something's wrong. You're living in a theoretical world, because it's never going to happen. Are there any statisticians in here who feel like I just led people horribly astray? Anyone? Okay, 1 point. Flying without a net here. The last piece is the coefficients. and literally, this is, you basically get a confidence level, a p-value for, we say p-value, but it's PR parentheses greater than absolute value of t. Like, really? Okay, I'm sure there's a good reason we can't label that p-value. But you can translate that and basically go on a variable by variable basis and say, what's my confidence level that this specific variable is actually predictive? The coefficients, pretty straightforward, right? So I can take the coefficients and build that completely out. Now what you may notice is that, so Saturday was my dummy variable. I expected that to go away. Sunday doesn't show up either. So that was where that stepwise regression said Sunday turned out to not be that predictive. So let's actually drop it from the model. So, basically we can go through the intercept 52, 193 times Tuesday, but now hopefully we're at a point where we're like, oh, 193 times Tuesday starts to make more sense because I'm working with these dummy variable values. And now it becomes very, very simple math. So this is the exact same table we started with. I've just plugged in the values to the formula in that predicted column. So now it's pretty straightforward. So I've got this Tuesday, so it's going to be 52 plus 203 times 0 is 0, plus 193 times 1, so it's 193. The rest are going to be 0, so 52 plus 193 is 245. That's my predicted value. Works out pretty easily. So it actually starts to make sense if I'm using my Saturday, which was my dummy variable. It wasn't even a variable included, so it's just going to be my intercept, right? That makes sense. And then Sunday actually got dropped, and that means it's also just going to be the intercept. But if you think about it, that makes sense because Saturday and Sunday kind of dip and are pretty similar. So Saturday and Sunday probably move kind of together. Kind of makes sense that Sunday didn't make it into the final model. One thing I kind of skipped over was I dropped Saturday. Like, why did I drop Saturday? And that seems to be, was certainly the question I asked, and then I Googled it, and it turns out a lot of people ask that question, like, which one do I drop? Doesn't matter. It's the beauty, because we saw that we dropped Saturday. We still had Saturday there. It was represented. The ultimate regression formula will completely change if you drop a different value, but the p-value in just R squared will barely change at all. And this was actually, and so now if I plug that back in, this is what it looks like. That dotted line is what I predicted, and the purple line is my actual data, and the red is the intercept. That's the base that I'm operating from. But if we step back and kind of think about the p-value and the R squared, so just looking at it as a human being, I had a statistics professor years ago who always preached always visualize the data. So my p-value said this model is significant, and I can just eyeball that and say, yeah, that dotted line, it's not predicting everything, but it definitely does look like a valid model. So it kind of reinforces the intuition that the p-value that it's legit. And then it said our adjusted R squared said it's predicting 46% of the variability. That actually makes sense too. If I look in the November period, it's not predicting the numbers going super high, and there are cases where it drops low. So even that intuitively now makes a lot of sense that with this data set, that prediction was 46% of the variability. Cool. Anybody think that's kind of cool?
Oh,
I'm gonna
Tim.
skill recurring pattern. I think it makes some sense. So I want to pull up this example because.
What was the question?
Oh, what was the question?
Yeah.
Is this the technique you'd use for using past data to predict future data? Would you use linear regression to do it? I probably should. It can be. Like linear regression, data scientists will even say like linear regression is crazy powerful. Like you definitely should understand linear and logistic regression because they're awesome. You don't have to do crazy, deep neural nets and stuff. So regression is super, super powerful and it definitely can be used for predicting the future. But I've got like a example I'm even more excited about that goes into some other aspects of that. But it kind of ties back with this. So, giving away company secrets, everybody wants to know how much traffic Jan is driving to the website.
From 2017, you can't even.
So here's our data set. What I wanted to, because these are mostly meant to be kind of educative. If you're trying it with yourself, you want to see, it's kind of walks through the same steps. It shows making the dummy variables. That's all fine. It shows this, puts it in plain English. Well, I want to show it, and it gives you the actual formula. So this formula, 42 plus 159 times Monday plus 181 times Tuesday. What's interesting, or what I think is interesting, is this defaults to Saturday as the dummy variable. If we look at the p-value is effectively 0, r squared of 0.736, I'm going to change it to Monday. This formula changes hugely. R squared didn't really move much at all. P-value is still good. So no matter what, and this is part of the reason I built this, because I wanted to kind of screw around and see what actually happened. But what happens is it actually moves my base point, right? Whatever that dummy variable is, because I picked something in the middle of the week, now my intercept is a much, much higher number, 214, and now I'm having to subtract stuff, because I'm now saying the weekends, I gotta remove numbers from it and kind of go down and go negative. So this is like my favorite drop down of the evening. So you know, I call it Fred. So, any other questions on regression? Actually, I think I have a couple other.
Can I use this model on my day trader account?
I don't know. Do you have a lot of money to lose? Do you have money you're trying to get rid of? Yeah, those are fancy those traders.
So Tim, quick
Yeah.
question. So a model like this, like a lot of times you look at average on a certain day and how different today is from the average. So the value of this is that it brings in like a lot of other values, right, over time. Like how does today of this week compare to today of every week, you know?
Yeah, and first time somebody asked me that question, I completely flubbed it. So the question is basically, why wouldn't I just do my average for Mondays, average for Tuesdays, average for Wednesdays, make those my coefficients, and you actually have something that's pretty good, but you don't then have the p-value r squared to give you a sense of kind of how predictive it is. So, and partly this is largely a pedagogical kind of example, but even in that case, it's going to give you something very, very similar. I've actually toyed with saying, what if let me also show what the formula would be if I just averaged Sunday, Monday, Tuesday, Wednesday, and you should see a pretty similar formula. You won't have any of the model fit data that goes with it. Great question. So hopefully we've taken, so day of week may or may not be super interesting, but now anytime like there's categorical data that I actually can impact, because there's the good news is super cheap to know that tomorrow is Wednesday. The bad news is no matter how much money I spend, tomorrow's going to be Wednesday. So if I figure out that like Wednesday is my awesome day, that has some marginal utility, but I can't make every day that my website's live a Wednesday. But there are some of these that I can impact. I can definitely have some control over some of my channels. So getting an understanding of kind of what's the level of impact of a different channel, understanding how that is actually driving an outcome, we get into kind of, happy time. So now we're excited about nominal variables. So typically when we're dealing with time, we're not actually doing regression by day of week. So here we're going to hit our last example, which actually covers a whole bunch of different kind of applications, and is actually buried in a lot of analytics platforms. So the question that for 20 years I would get was, hey, this number went up or it went down, and we know intuitively that there's signal and there's noise in our data, and when we see a number move up or, it never stays perfectly flat. So how much does it have to move up or down for me to say, this is something I need to dig into? So we're gonna walk through another one of these like step-by-step things and sort of see how that works out. So I look at this and say, I'm looking at the last 7 weeks of data. Let's say our metric is traffic, sessions, visits, whatever. Could be any metric. And I can see that last week was down from the week before. But was that due to noise, or was that like a real issue? Should I care about that? So what I'm gonna do is I'm actually gonna break the data down into a more granular format. So I started out with 7 data points, but it's web analytics data. I could break it down to hour if I wanted to. I'm going to break it down. I'm going to turn those 7 data points into 49 data points. So I still have the same data. I'm just looking at it daily. And I want to do that because it's going to actually help me build a better forecast. So now we basically have split it into the last 7 days is last week, and the 42 days before that are kind of the week before that. So the data of interest is our last 7 days, and we have our data for context, which is basically our training data. So we're going to train a model using really not much data. We're only using 42 data points. Here's where things get fun. So we see a pattern in that data. And it turns out there are a couple of patterns in the data. So what we're going to do is we're going to do what's called time series decomposition, which is just so cool. More exciting than linear regression with nominal variables. So going to have to ride along with me here. It's not the most awesome animation. I'm going to take this and I'm going to squish it up to the top. So watch me, keep me honest, pick some little, I'm going to make it a little squished up to the top. So same data. Everybody believe me, nothing up my sleeves. I've not changed anything, I've just put it up at the top. So we look at this and we see that there is a recurring 7-day pattern. So in marketing, we talk about seasonality a lot. We're like, oh, there's back to school, there's holiday. Well, in a lot of websites, there's a season that's only 7 days long. There's a recurring pattern of every 7 days. So we can treat that as a seasonal set of data as well. So what we're going to do is we're going to say how much of that recurring pattern, let's pull that out into just a seasonal recurring thing, which, if you were paying really close attention, looks a hell of a lot like a linear regression by day of week predictive model. This is not technically doing a linear regression like we just did. Conceptually, it's about the same, because now I've said, what's the best fit I can put in there where every Monday's the same Monday. Monday's exactly the same. So it looks similar, but it's actually exactly recurring pattern. And I said, how much of that can I explain with an exactly recurring pattern? So then the decomposing is I then subtract those values out of the original data, and then I basically apply a moving average. It's a little more involved than that to kind of smooth it out to give me a trend component. So I've taken it out, and now I've got this trend component that says, how's the data actually trending once I've removed that recurring 7-day cycle? Then I take that out, and then what I have left is the noise. So the actual scale of the y-axis is very different between these three, but you can't really see the stuff otherwise. So now that's like all there is to it. If I took and drew a line at any given day, if I add my seasonal component plus my trend component plus my noise component, I'm going to get exactly the actual component. So, and forecasting models kind of do this all behind the scenes, so we're kind of looking at what's actually going on behind the scenes. So, I'm going to take my first 42 days of data, and using just those first 2 elements, the seasonal repeating pattern and the trend, because how was it trending, and I'm going to forecast those forward for the next 7 days, which was actually the last 7 days, so we're kind of forecasting something in the past. So that's what I would have expected if I just looked at the seasonal component and just looked at how the data was trending. That's where my forecast comes from. I know my forecast is not going to be perfect. The world's a noisy place. But how close do I expect my forecast to be? Well, that's where I look at the random component. Because that random component, that noise signal, it might have been bouncing along like this, or it might have been bouncing along like that. That was telling me how much noise was in the data. So I can use that and how much that's varying to put a prediction interval around the forecast. So this is a 95% prediction interval. 95% of the time, all things staying equal, I expect my actual results to fall within that band from my forecast. And then I can come back and put my actual data on it, and then I can actually start saying, wow, last week, 5 out of the 7 days, I was below my 95% prediction interval for what I expected. That actually makes me think something might actually be going on. It's worth digging into farther. So that was kind of for overall, all traffic, a single metric. What we just identified were anomalies. I might want to split it down by different segments. I want to look at it for each channel. I want to look at paid channel, organic search. What did I just say? Paid channel?
Yeah.
So it's paid search, organic search. Lose in English. Lose in I may want to look at multiple metrics. So I used to do this for orders and revenue and traffic, kind of combine those together. And I can programmatically say, count how many of those anomalies did happen in the last 7 days. Put those together, I wind up with a whole jumble of these, and most of them are going to fall within that band, but now I've actually got anomaly detection. So if anybody's using Adobe Analytics, we just walked through what was called the Holt Winters forecasting methodology, and that is how Adobe Analytics does its anomaly detection. It's basically building a forecast. It takes the last 30 days, builds that forecast, puts the bands around it, and then checks to see if the actual data fell within that.
So Tim, can I if I were to take this and say just use the aggregate, can I run like a t-test or something? Similar to what, A/B with, it wouldn't tell us necessarily why, but like is there a difference between last week and this week? If like I just were to quickly do this?
Yeah, I mean that's another, if you just, yes, potentially. If, not sure. Maybe. So this actually, I mean, the thing is you can start feeding more stuff into your forecast. So even like when Adobe does it, they preload holidays because they know the holidays are going to throw stuff off. So the more stuff you can kind of put into your model for a forecast. I mean, that's like, it's the simplest world of forecasting. This, literally I just finished building last week, and we'll see if I remember which dates to look at. So most of the time, anomalies don't show up. So that can make it a less than thrilling demo. Dang it. No, I feel like this should be an anomaly week. So I'm gonna, no, I think I'm gonna find it. Yeah. Let's see if I remember. So this just kind of, again, walks through sort of the different pieces. It actually does and on this one, it throws in it's a big, long range of data. So you can actually see the different scales, like the seasonal going from 50 to minus 100, the random kind of goes different scale. So, because that was starting to bother me that I couldn't figure it out. And yet, I'm not going to have an anomaly. I bet if I've been meaning to ask you what happened in July that traffic dropped.
This July?
Yeah.
That's a great question. I'll get back to you on that.
Yeah. Why is LastPass trying to fill in? Come on. I'm going to show an anomaly with it. There we go. Right? And again, it sort of matches what our intuition would expect. It's not an enormous amount of data, but we actually get that we had an anomaly. So that is the I'm trying to computer can do it. So that's just like one little example. So once you get into kind of the statistics and modeling world, there are like a million things you can do. So definitely prediction. There are lots of other algorithms, anomaly detection. There are tons of different ways to do anomaly detection. We just looked at one of them. Linear regression, we're predicting a continuous variable, logistic regression, classification. What if I want to predict the likelihood that somebody is going to make a purchase from my organization? I get into the world of kind of classification trees, a whole other world we're not touching on. I could do kind of looking for anomalies, various ways, finding outliers, how to identify the outliers, because I want to dig into those. Jamarius gets another visual on the screen, I think. Was that yours? Yep. Yeah. Cluster analysis. I want to do unstructured, unsupervised learning based on a bunch of data that I'm feeding in. So that is like a huge topic of all the different things we can do, but hopefully we talked through a couple of examples that were kind of just the basics and were simple, and you can kind of quickly imagine like, wow, and how would I do something, how would I do this other thing, how would I extend it? There's lots of things we can do. So, summarize, and this is my biggest takeaway for any analyst that I'm talking about. I used to say I wanted to become a data scientist. That lasted for about a month. And I said, that's never going to happen. And it's not about becoming a data scientist, but it is for those of us who aren't data scientists. If we bring some data science into marketing, there's a lot of things we can do that are a lot more valuable than what we have historically done with digital analytics data. So, I said this is all of those examples. There are actually, I think, 2 other ones there as well. At that one, it's a GitHub Pages page. I am legally obligated to plug the Digital Analytics Power Hour podcast. I have stickers if you want a sticker. I think I might have a build on this. Yes, there it is. Now take the picture. Now you'll remember. The premise of the Digital Analytics Power Hour is around like trade conferences, trade shows, where industry conferences where you wind up in the lobby bar late at night talking about industry stuff, half drunk or fully drunk, and being very passionate about it. And so there are 3 of us. It's actually myself, Michael, and a lady in Sydney, Australia, Mo Kiss, where we usually have a guest on, and we basically dive in and try to figure out these are topics that are of interest to us. It's our excuse to tell people like, hey, I have a podcast. Can I talk to you for an hour and a half? It's a lot easier than will you talk to me for an hour and a half. They don't go for an hour and a half. They are almost always under an hour. So they vary between 45 minutes and 1 hour and 2 minutes once. Just couldn't cut it out. I obviously am passionate about this, if a little strange. So I'm easy to track down on Twitter, on the email. And with that, any questions? Any closing acceptance remarks? Exciting time. We're losing people and they're forgetting to take food.
Well, I just wanted to thank everybody for coming and let you know. When we leave the food out, thank you.